Hello and welcome to the video. Again, it's another one of those. I'm up here. This is Simeon. Say hello, Simeon.
Hello, Lee. Hello, everyone.
So, about 2 weeks ago, we did a video where we were looking at some of the new features of ExpressLRS version 3.0, which is still in release candidate as we're recording this, but on its way to being something that we can all fly and use. However, I'm sure lots of pilots have already downloaded it and had a go. Now, one of the cool things is that this gentleman here was quite happy to come along again and answer your questions about ExpressLRS version 3.0. Well, ExpressLRS generally, actually. And I've had some fantastic questions from viewers, subscribers, and Patreons, as well as one extra one that we're going to cover at the end. Now, I'm going to put time codes down below to each of them. So if you're interested in your particular one, you want to jump to it, you can. However, it's probably worthwhile, some great questions in here, just getting a cup of coffee, cup of tea, settling back and listening to the whole thing, because actually I'm probably going to learn things in this video as well. Now, this gentleman here is one of the developers of the project. He knows an awful lot more than I do about this stuff, so he is definitely the expert in the room. I'm here just to ask your questions, I guess, which is quite nice for me because I can just relax and learn with you as well. So the first question is from Alex R. And Alex R said, I fly far without telemetry. And the most important thing is distance. So this is a range related question. Why, starting from version 2.0, the option to flash without telemetry has disappeared? So he would like to flash without telemetry because his thinking is if he flashes it without telemetry, that's going to give him more range. So what's your thoughts on that? Is that something that's either coming, or is that the best way to extend your range with ELRS?
So for range, we'd recommend bumping down the packet rate to something sensible. So something you're comfortable with in terms of latency to packet rate. So besides that, the flag that we used to signify to disable telemetry entirely is gone because now it's part of the Lua script. So now if you go into the Lua script and in the telemetry ratio option, if you scroll all the way to the end, you'll see there's an option to turn off entirely the telemetry. So if you don't need it for some reason, then you can disable it entirely and it's going to give you a more consistent RC link. But for long range, I'd highly recommend using at least some sort of telemetry.
Fantastic. That's a brilliant answer. Thank you for that. Next one then is from a gentleman called Peter Venzor. Fantastic name. Does anyone know how ExpressLRS compares to DragonLink 2? Does it have the same range? Now, DragonLink, Peter, is quite a legacy system. There are lots of long range systems around, and it also depends what you mean by long range, because long range systems like ExpressLRS, the longer wavelengths with the lower packets, also things like your Crossfires, also things like DragonLink, there's loads of options available now. So it's an interesting one to answer, because unless you know what you mean by range or long distance, it's hard to answer. But in terms of Peter's question, any thoughts or comments on that one?
If we take into account the raw hardware and performance of both links, for ExpressLRS, we use LoRa for most of the packet rates, but on 2.4 you can also use FLRC. But for this case specifically, since we're talking about either 433 or 868/915 for DragonLink, on ExpressLRS for those frequencies we use LoRa exclusively. So compared to DragonLink, which uses GFSK, it's going to give you a lot more range and a lot more penetration, purely because LoRa can go at the noise floor or sometimes even below the noise floor and still pick up the data.
So Peter, I know that's not really answering the question, but then without a little bit more information, you can get quite a lot of range with ExpressLRS. If you use the lower frequencies, the higher powers, the lower frame rates, those kind of things, you can push it tens of kilometers potentially if you really want to. Next one is a question from Kanan Barak. He understands that there was only 12 channels available on ELRS, and will it be 16 now? Now, this was something that came out of you and I talking about one of the cool things in version 3, which is we now have full range channels for all the channels, which as a fixed wing pilot, again, I'm still very, very happy about that. But he read things about 16, 8, 12 channels. So how many channels are there in ELRS?
If you switch to 8 or 12 channels, you get those 8 to 12 channels, including the aux1 channel, which is the arming channel, which unfortunately for those two modes are going to be a binary channel, binary switch. So you still have to use it for arming or throttle cut. And it has to be high in order to engage the optimization that we have in the link.
Yep. We'll come back to that point in the next question.
Yes. But if you switch to 16 channels, you get all of them at full res, including the aux1 arming channel, which still has to be put to high in order to engage those optimizations.
So the bottom line is, Kanan, is that you can actually decide whether or not how many channels that you want, but if you don't have the full 16 channels as the full resolution mode, then your auxiliary 1 channel 5 is a binary channel. That's just one of the things that you do, but you can choose is the answer. Which leads us nicely into Martin Mathis's question. Martin was confused when we were talking about the fact that even in full resolution mode, the channel 5 has to be high. We mentioned this and you mentioned it was a caveat and we kind of joked about it. It's worthwhile as maybe then answering for Martin's benefit what actually happens and why having channel 5 or auxiliary 1 in a high position before you fly is a good idea, because it's not just about having it as armed. The system actually uses channel 5 in a high position to do other stuff, doesn't it?
Yes. So we're currently trying to get away from the whole channel 5 being high requirement, purely because, well, the RC link has developed so much that there's so many people and so different kind of use cases for it that there is not really a necessity for it to just do that. So currently the arming state, which we use internally in the code, is used to check for dynamic power. So if to enable the dynamic power boost or not. The OLED menu, which is gets locked the moment you turn on the arming channel, as well as the other features such as the sharing of the bind, the VTX admin, and the upcoming VTX control in 3.0.
So actually, it does a lot. So even if you're flying fixed wing, when you're using ExpressLRS, when you're ready to fly your plane, have channel 5 go into a high position. So as a fixed wing pilot, I would make it so that when I turn off my throttle cut or make the throttle active, I would then set channel 5 to be high, and then I get all of those additional things turned on. Great question, Martin. Thank you for that. Vincent asked, is MAVLink support something that might be implemented in the future?
So for MAVLink, it's been a bit of an endeavor for a couple of our developers. We've been trying to find a solution to implement MAVLink without compromising the current state of the RC link. And we've already have a couple of solutions that are in the works, and those will be on flashed as a separate firmware and not something that goes alongside the RC link.
Fantastic. Okay, so the answer is it's been worked on. Watch this space. Great question, Vincent. Now, a couple of people asked this next one. Pressure, FPV Merch, and Verdi asked this. SPI ELRS receivers, the ones that are typically starting to get built into flight controllers now. In fact, I was looking at the Maytech website this morning with the one that has ELRS built in as well. So it's exciting to see that even people like Maytech.
This gem.
That very item.
That's the F405 WDE from Maytech.
It's kind of the replacement to my beloved F405 wing, but it now has an ExpressLRS receiver in it. I've almost pressed the button on getting one in because I had some questions about it. Anyway, lots of them now have these, and typically those receivers are connected via SPI to the flight controller. The question is, for SPI ELRS on 3.0, will it be troublesome to have two transmitter modules is SPI whoops affected or not? So sometimes with this, the way the update works for the flight controller is the flight controller and the ELRS receiver are kind of flashed as one unit. So I'm guessing it's all around that stuff. Any kind of advice for people who have SPI receivers?
So for SPI receivers, the main advice that I can give people is that if you already upgraded the rest of your fleet that's not SPI to 3.0, then there's not that big of a deal. 3.0 can still bind to 2.0 receivers. This is mostly added as a compatibility for these SPI receivers that are built into all-in-one flight controllers. And if for some reason you're not confident in using 3.0 with backwards compatibility with 2.0, then you can always get a cheap radio module that you can flash to 2.0 and use exclusively with your whoops and other SPI-based flight controllers.
Fantastic. And that answers Kevin's question as well. Kevin asked it very simply. He said, can you bind a 3.0 radio to a 2.0 receiver? And I think, Kevin, we've just had our answer. The answer is yes. This is the first version that I'm aware of ExpressLRS that allows you to do different versions on the radio and receiver. Until now, you've always had to be on the same major version typically for everything to work well.
Essentially, this is because the SPI-based receivers are very slow in being updated. So this is just to make sure that the people that have already bought it aren't left out in the dust compared to the ones that have serial-based receivers.
Fantastic. Next question then is from Andrea Bucotti. Sorry if I'm pronouncing that wrong. English guy trying his best to pronounce what I think is an Italian name. Is there any plan for a PWM receiver that's able to send VBAT telemetry back to the radio? He's flying DJI without a flight controller, so he doesn't have any way to get the Happy model PWM receiver to send that information back. As far as I'm aware, there's already receivers that have that on it, aren't there?
Yes, there should be a couple of receivers from, I think, Maytech. Okay. That have been released already that do include the voltage divider for VBAT telemetry. And if you plug in a battery to the PWM receiver, then yes, it should be able to read that telemetry and send it back to the radio.
Yeah. So Andrea, yes, that kind of already exists. It's something that's around. You might not have seen it. If you're struggling to find it, if you pop a comment down below, I'll pop a link in there for you. So the next question is one from me, and it's going back to Vincent's question about MAVLink, because I'm another big fan of MAVLink. It's one of those protocols that gets used a lot with things like Ardu Pilot, Ardu Copter, Ardu Plane. I play with all that stuff here quite a bit, as well as things like INAV too. Now, one of the things that I've always been wanting to be able to do is get the MAVLink telemetry shared via Wi-Fi to a ground station by the side. That tends to be the way that lots of us fly the larger models with Ardu Plane. Any thoughts or ideas about having not only MAVLink connection between the radio and the receiver, but then having maybe the backpack system inside the radio, then allow you to share that MAVLink stream with a laptop?
Yes, there's a couple of ideas that we have in mind. One of which is that the MAVLink, technically at this time it's called the receiver, the ground-based unit, would create a Wi-Fi access point that your antenna tracker, your ground station, your any other peripheral that may need a MAVLink stream from the UAV can connect to, and then the MAVLink module is going to transmit that MAVLink stream to all of the components that are currently connected to that network.
You guys, honestly, I can't believe you guys sleep at the moment, because you have so much stuff going on. So I'm very excited. So thank you for that one. That was a one for me. Next question, a gentleman called Tim Tuxworth. So we talked about the fact that at the moment there isn't any plans for the project to support SBus. I know you guys see SBus as a kind of a legacy system, but there are still lots of things out there that still use SBus. But his question was specifically about why not use something like SPI or CAN bus for radio control transfer between the receiver and a flight controller.
So for SPI, it's again back to the whole issue with SPI-based receivers and all-in-one flight controllers. Is first of all, you need the autopilot firmware, in this case Betaflight, INAV, Ardu Pilot, etc. to actually implement the entire ELRS protocol with all the feature sets. And not only that, but also have enough processing capabilities to execute the ELRS code as well as all the other flight controller code that it may need. And especially on these smaller, more budget all-in-one flight controllers, the F411 processor doesn't have nearly enough capabilities to run both the autopilot firmware and the high demand rates that we have in ELRS 3.0.
Fantastic. So at the moment, CRSF is where it's going to be for the time being, everybody.
For CAN bus, we would need some dedicated hardware because it's a very unique protocol. And currently, I don't think there's anything outside of, I think, Pixhawk and ArduPilot that use the CAN bus. So it would be a very difficult thing to actually code and test.
Okay, last couple of questions. Crease, this was a great one. He has heard, and again, we're getting into some of these questions at the end are things that people have heard and may or may not be right, but thank you for asking this. He's heard that you can't do the CLI command stuff over the Wi-Fi connection to Betaflight or INAV.
So currently there's been a couple of issues with the wireless functionality to do the configuration. And a couple of those are stemming from the way the configurator as well as the MSP frames are being sent and received by the flight controller as well as the configurator itself. So once those configurator bugs are ironed out on all the flight controller firmwares, then it should be pretty smooth and easy to use.
Right. So it's not just about ExpressLRS for that one. It's also about the other projects as well. Right. Or penultimate question. This one is from Charles. What dependencies on OpenTX are there? Let's branch that out to OpenTX and EdgeTX, because I've heard that there are older versions of OpenTX aren't great. There are minimum kind of versions that are recommended. Is that the case?
Yes, there is a minimum version requirement. So the main requirement that you need from your radio is to support the CRSF SHOT protocol, which if you have any relatively new, so within the last year or two of OpenTX or EdgeTX, then your radio should be able to run ExpressLRS. Now, for the higher packet rates, the limit is the baud rate. So if your radio cannot do 400,000 or above baud rate, then you will not have the ability to run the much higher packet rates.
So I think the advice would be, from me, is if you're going to invest heavily in ExpressLRS, bite the bullet and update your radio to the latest and greatest. It'll give you all the best features. And modern radios like the RadioMaster TX16S Mod 2 and things like that have high-speed inverters that allow you to run very, very quickly and talk to the module at high speed. Older radios that are OpenTX based didn't typically have high-speed inverters, things like the QX7, those kind of radios. So although they will work with ExpressLRS, you cannot get the really high speeds because the inverter won't support it. It's a hardware limitation. We used to have that same problem with Crossfire back in the day, which is why you could buy those little kits that you had to solder in to try and fix the problem. Last question. Now, this is an interesting one because this is something that I was made aware of. I had a question about somebody talking about whether or not ExpressLRS was hackable. And it appears, looking at the detail, is somebody released like a security bulletin about it, about one very specific thing to do with ExpressLRS. And as usual, the hobby has gone into fits of craziness with lots of people doing clickbait and forums have gone mad. And to me, it feels like it's almost a non-issue and it's been blown up out of all proportion. But I'd be interested to get your view on what it actually is and how likely it is to affect us, bearing in mind that you guys are constantly updating the project and that any security vulnerabilities that were found, you'd fix anyway.
In this case, it's a pull request that was opened in February of this year from a security researcher that has found a issue with the random number generator that we use to determine the hopping sequence for the transmitter and receiver. So for those that don't know, the hopping sequence is basically the pattern that the transmitter and receiver will change channels so that they don't conflict with someone else or transmit too long on the same frequency in case there's other things that are transmitting in the same frequency band.
Right. So it's just a way to randomize the channels that the system's using to kind of keep everybody out of everyone else's way when you're flying.
Yes, essentially that.
Okay.
So because especially on 2.4, because we have so many channels, the amount of these channels that we have is very big. Therefore, the ability to actually interfere with one another is usually very small unless the sequence that was generated has a lot of common channels. So in certain cases, it's usually very, very unlikely that two transmitters that are transmitting at the same time on occasion may hop to the same channel and try to transmit, and then the receivers obviously on both sides will not be able to understand anything out of that. A proposed fix by this security researcher was to mask this these bytes that are used to generate this sequence, so that in case someone maliciously wanted to, for example, take over your drone, would not be able to get the sequence and start transmitting on the same pattern. But because the way the protocol is made and integrated, it's not really an issue, because you'd need a extremely powerful transmitter to overpower the original one in order to not have the receiver recognize the original packets that are being sent.
Right. Okay. So what it boils down to is that there is a way, if you're being smart, you could listen to the radio traffic between the radio and the receiver, figure out what that special magic number is that has been encrypted that is just for the link, and then you could then clone essentially the transmitter to try and take control of the drone. However, the original radio is still on, so you're both talking. I guess what would happen in that case is actually what would happen is the drone would fail safe. But I think if you were going to play games like that, there are far easier ways to take control of a drone, including going up and stealing the radio from the pilot that's currently flying it.
Looked at on paper, so without taking into account other real-world scenarios and things that may take into account. But overall, the link was never meant to be encrypted or secure in the first place. It's the whole binding phrase or the whole binding system is in place to make sure that when you're flying with a friend or when you're flying in a group, there's a very unlikely chance that you're going to stump on one another and not being able to fly.
Right, because in lots of countries, using an encrypted signal like that isn't legal anyway, is it?
Yeah, in a couple of countries, there's legislations that does not allow for any ham transmission to be encrypted. And not only that, but encryption is also a very computationally expensive procedure that would negatively impact the performance of the link.
Yeah, or we'd have to have much more expensive kit hardware at each end to accommodate the extra processing power that was needed.
Essentially.
Okay, well that helps explain it a little bit for me, and I feel a lot happier after talking to you about it, so thank you for that. So there we have it. We've been going for quite a while now. Hopefully that was interesting for those of you, and thank you to every single one of you that left a question. I'm going to continue to monitor what's going on with ExpressLRS version 3.0. Big thank you to all of the developers for all the hard work in this project. This project is now becoming one of the cornerstones, along with things like the multi-protocol module, Betaflight, INAV, and a handful of others, is the kind of stuff we're relying on. If you are watching this and you have the ability to kick these developers a couple of bucks, I definitely would recommend that you do. It's something that I do just to keep the project running and keeping going on. I know with the activity that's going on the project, if there was a massive security issue, I'm pretty sure guys like this would work very hard to sort it out very quickly anyway. So I'm pretty relaxed about that. So Simeon, thank you so much again for the time today. And maybe we'll talk when ExpressLRS 3.0 is finally released. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.